Hey guys, in my last video, we containerized an Azure Pipelines agent on my Mac. But what good is an agent without pipelines that actually work? Today we're building on that foundation. We'll take a basic pipeline, evolve it through real-world challenges, from tool installation to pipeline variable sharing and deployment strategies that you'll be able to use and adopt in your enterprise environments. In this video, you'll understand how to share credentials as variables across jobs and stages, deploy to multiple environments using the dry principle, and work around possible Azure DevOps billing limitations. Let's start where we left off. I have my containerized agent running. So I've got 3 of these containers running, 3 agents. And I'm now thinking that I'd like to deploy into my AWS environment. So I build into the pipeline the steps needed to use AWS IAM roles anywhere, where we follow best practices on using temporary credentials. If you missed how to set that up, check my other video where I show the complete IAM roles anywhere configuration process. But when I try to deploy to AWS, I hit my first roadblock. I cannot install the AWS credential helper. Here's the problem. So looking at this pipeline log for installing the AWS credential helper, it's saying wget command not found. Let's first have a look at the pipeline. This first step, where it runs a bash step of doing a wget call to this URL to be able to get the binaries for the AWS signing helper, which comes from this documentation from AWS. The first step of using IAM roles anywhere into your pipeline. So I just copied this off here. This URL came from this AWS documentation, getting temporary security credentials. So the first error was that it doesn't have the wget tool. And where is that defined? If we look at our Docker file, this Docker file, when I build the agent, it only installs these particular packages. This is very basic. And so I have my v2 file here, where if you can see, I've got a few other packages that I figured that I needed after running through several times what the problem was, because I also ran into an issue with AWS CLI command not working, because obviously I didn't install that. So I had to do a curl call to the AWS CLI and download the binaries, unzip that, and install that. I'll just rename this to old and change this to Docker file so that I can rebuild it by doing a Docker compose down command, Docker compose build, don't cache, so rebuild from scratch, and Docker compose up so that it will do a full build, removing all 3 containers and rebuilding it. Okay, so it's done building. Took about a minute to do that because it had to pull these binaries and install them. Okay, so it's showing we've got now the 1 new agent. If we try and run this pipeline again, we can see that it ran into an error. It's complaining about error retrieving credentials from custom process. Rosetta error failed to open at this ld-linux x86-64. So here's what happened. My Mac uses Apple Silicon. If you've heard of Apple Silicon M1, M2, M3, and currently we're on M4, that's based on the ARM architecture. But I was using an x86 architecture which is using an Intel-based Linux image in this case, trying to run Intel-based libraries. It's like trying to use Windows software on a Mac. The instruction sets just don't match. Let's have a look at the pipeline again. We are failing at this step when it's using this AWS signing helper. And if you notice, this is using the x86 binary. Let's have a look at the page again where AWS gives us the download URL. See, we're getting it from this Linux x86 architecture when I should be using this AARCH64 architecture, ARM architecture 64 for Linux. And so if we go back to our test pipeline here, I'll copy this one where this uses the ARC64 architecture. Paste that into here. Perfect. Now it's running fine. It was able to install the AWS credential helper, obtain my AWS credentials, and I have here a step on configuring the AWS CLI, which just does a basic AWS STS get caller identity call to be able to confirm that I'm able to use and make a call to my AWS environment. Now, let's start talking about jobs in Azure Pipelines. Think of a job like a separate worker. Each job runs on an agent and gets its own execution boundary with fresh workspaces on the disk. Jobs can run on different agents or different machines, but there's no guarantee multiple agents or multiple jobs might use the same agent depending on pool availability and demands. By default, jobs don't share variables unless explicitly configured. So here's the problem. I get my AWS credentials in job 1. So this is my pipeline, and the way it's currently structured is very basic. It just has steps, and the collection of these steps form a job. So when I have a job that gets AWS credentials, I want to reuse it for other jobs, like a job to build, a job to deploy, and a job to test. So in Azure Pipelines, it's not that straightforward to share the variables from one job to another. There's a certain syntax that you have to follow. And in pipeline 3, I'll show you the correct syntax to share variables between jobs. Here you can see stages in stage, but let's skip that concept for now. Let's stick to jobs first. So jobs, there are several jobs in a stage, and you can have several stages in your pipeline. The most basic unit in an Azure pipeline is your step or your task. So again, multiple steps form a job, and multiple jobs form a stage. So for here, I've created a get AWS credentials job where we have all those steps that we had from the previous pipeline. I just built on it a bit. And the second job is using the AWS credentials. Here you'll notice how I've constructed the exporting of these credentials into variables. First, I got the AWS access key ID, the secret access key, and the session token. Those are the main values that I need to be able to sign into AWS and deploy my resources into it. There's a certain syntax that we need to follow. This came from Microsoft documentation, where you just define it as an echo VSO open bracket task set variable equal to the name of the variable that you've defined it to. This is the important bit, is output is equal to true. Then the name of the variable that you want to store it as. When I use it in the next job, I then define it under the variables definition of the job. And there's a certain syntax again for using the variables that I've outputted from the previous job by putting in the word dependencies, then the name of the job. So if we look at this job at the top, the job name is get AWS credentials, outputs, extract credentials, which I've defined in my condition above here. Then the name of the variable that I've defined above in the previous job. So all these are variables that were defined from a previous job. Then the next steps, just make calls to AWS. This one doing an STS get caller identity call and doing some other basic AWS calls to S3 and EC2. Let's copy that, update the pipeline, run it again. So we can see in this step that we were able to extract the AWS credentials. And the next job is that we were able to use the variables that we've defined from the previous job into the next new job. Great. So next we can go to the next level up, or the next concept up, which is our stages. Remember what we said, that jobs are like workers within the same stage. And stages, they're like logical boundaries in the pipeline. Like you can do further separation of your pipeline into more logical chunks. So let's say you can have a build stage, a test stage, and a deploy stage. Then you can have your stages targeting different environments, your dev, test, and prod environments. So in my next pipeline, pipeline 4, what do we have here? We've just restructured our previous pipeline where we have a stage of acquiring the credentials. The job here is to get AWS credentials. Then instead of another job of using the credentials, I've split it off into a different stage. When we exported the credentials here, it's the same thing of exporting these variables out with the key is output is equal to true. Now the difference with using or consuming the variables from another stage is that we're using the term stage dependencies in that syntax. And then the name of the stage, which is acquire credentials, the name of the job, then outputs, and everything else is the same as when we're using a variable from another job. So the rest here is the same. We're doing a call to STS get caller identity and EC2 and S3. Let's do the same thing, update the pipeline. So you can see we've now got these stages and one job in each stage. So each stage can really have multiple jobs in it. Here we're just showing you a very basic structure where you have multiple stages. It's doing exactly the same tasks as the previous pipelines, but it's just split into different stages. Yep, and it's worked fine. So my problem is that in the real world, in enterprise environments, you typically want identical deployments to your different environments. You've got dev, test, and prod. We can copy and paste the same code 3 times, which I've done in this pipeline, where you acquire the credentials, you use the credentials from based on our previous pipeline, and copy and pasting that, changing it into a different name, using a different name for your stage, and changing different little bits of stuff in here. So we know it's going to work fine with this pipeline, but it violates the dry principle, dry for don't repeat yourself. Change it once, not 3 times. We're going to skip that method of test pipeline 5 and use the matrix deployment. With this, it's the same stage for acquiring credentials, but here we have something a bit different called a matrix deployment. A matrix deployment is where you define it using this job where you have a strategy. You have a max parallel attribute here where you can have multiple jobs happening at the same time. And in your matrix, you can then define different environments. In my case, I've defined 2, a dev and a prod environment. Within each environment, you can have its own unique variables. Then it can have a global variable for your job, for this job, where I define all of those. Then the same steps where we do our basic calls to AWS STS get caller identity, EC2 and EC3. Before I deploy that, I would just like to expand the number of my agents to 3, because here we're saying I want to deploy this at the same time using 2 of my agents. So while it's deploying that, we've got these 3 agents, and we can see that it's running build. It's using this agent number 3 to do the deployment for the stage 1. Stage 2 is what we're interested in, seeing what will happen. Okay, so it deployed successfully, but one thing you would have noticed is that it didn't deploy these 2 jobs simultaneously. So in theory, it should have deployed it simultaneously. If we look at the parallel jobs here in the pipeline, we can see that for Microsoft hosted, the default is you have 1 parallel job available for free, as well as my self-hosted, in our case, where I have my Docker containers running the Azure Pipelines agents. And I can see I've only have 1 parallel jobs available. So that explains it. And if I want to change it, I will need to do it in the organization level and change it into a paid parallel job. So for most personal projects, this is fine. Having just the default parallel job is okay. But in enterprise environments, teams often buy multiple parallel jobs to speed up deployments. So you have to be aware of this. Let's go to the Azure DevOps pricing page. And you can see here under Azure Pipelines that if you want to increase, so this is free. If you want to increase to 1 under Microsoft hosted agent, you have to pay $61 a month. And for self-hosted, that is $23 a month. Okay, so sometimes you actually want sequential deployment. Dev first, then prod only if dev succeeds. Now this is standard practice so that you can catch your issues early. And that's where we have our next and last pipeline, where we have the sequential deployment by still using the matrix approach, so we can leverage on having the unique variables for each environment, as well as stick to the dry principle of 1 job definition for multiple environments. Then we add on safe deployment, but just changing the max parallel here to 1 environment at a time. So all we need to do is change this max parallel to 1, rerun it, and it will do exactly the same thing. Now, you probably wondering, it didn't matter because the previous run with a max parallel 2 already was doing that. The problem with that is that I've noticed in previous runs with max parallel 2, it can run the production environment first before the dev environment. And this is something I cannot control the sequence of. I find that limiting the max parallel to 1 ensures that I always do the dev environment first before it then proceeds to the prod environment. Okay, so it's deployed successfully. To recap, what we learned is the first one would be sharing of variables in our pipeline through multiple jobs and multiple stages. Jobs are workers that are within the same stage, and stages are logical boundaries in our pipeline, like build, test, and deploy phases that we can use to target different environments. Each of these needs different syntax for variable sharing. For matrix deployments, we're using the DRY principle to avoid copy-pasting coding. What we have is one job definition and then multiple environment configurations. We have also had a look at the billing constraints, where we're given a free tier of one parallel job. But in reality, in enterprise environments with multiple teams deploying at the same time, you'd want to plan your pipeline strategy around your budget. We've also encountered some architectural, being aware of what our container architecture is to our host. So even though I'm running a Mac OS on my machine, the Docker container runs on an Ubuntu Linux OS. However, it follows the same architecture as my host, which is ARM for Apple Silicon. So you just need to be aware of the differences of x86, Intel and AMD machines, and Apple's ARM-based machines. That's it. In my next video, I'm hoping to evolve the pipeline further, maybe use templates to make this even more DRY, plus exploring persistent storage, perhaps for Docker agents, so our build caches survive even container restarts. Thanks for watching and happy building.